Welcome to Tolomatic Rodless webinar part 2. I'm Tim Najelski, an application specialist. Right now we want to look at our heaviest duty and most versatile actuator, the B3 series. Let's take a look at the heavy duty features. The B3 is available in one of its configurations is a screw driven actuator. We have two sets of recirculating large diameter ball bearings, one on each side. These circulate between the carrier and the extrusion. The internal rails are set up for parallelism. There's a rail wedged into one side. Then on the other side, the rail is put in there, and behind it, there's a wedge rail. And along the top of the extrusion, about every inch, there's an adjuster screw. These are adjusted so that these two rails are in parallel with each other. And then once they're in parallel, they are checked with a tension gauge. And this gives you smooth rolling friction along the entire stroke of the B3. And the B3 is available in both ball screw and solid nut. Ball screw being the high force, more durable configuration. Yep. There are several mounting options with the B3 as well. We can have tube clamps with 4 attachment points, and we can have mounting foot mounts with 2 attachment points. The extrusion here, there's actually 3 sides that could be mounting. There's T-nut channels, and they can also be used for switches to control or to indicate home and to travel. There's also some other carrier options that can beef this up. We'll take a look at that. The B3 is also configured so that we can mount other manufacturers' motors and gearboxes to it via the Your Motor Here, which is found on our website. This actuator is approximately IP54 sealed. We have black anodized aluminum on the extrusion heads. The dust cover is stainless steel. And there are internal bumpers to prevent jamming in most situations. Let's take a look at some of the other carrier designs here. The B3s can produce up to 2,700 pounds of force, the B3 S20. The heavy duty carrier design, you can put more than 2,000 pounds directly on these actuators. They're also designed for heavy side loads if the load is out, not centered on the actuator. With our belt drives, we can get up to 60 inches per second. Excuse me, with a short, large B3S20, we can get up to 60 inches per second. There are 6 extrusion sizes. 3 of these sizes, 10, 15, and 20 are for our standard. And then we also have this dual 180 wraparound carrier, but we'll take a further look at that coming up. The B3 is also available in a belt drive configuration. The belt drive gives you much higher speed and longer lengths to move your load. The carrier is the same internal rails that are adjusted and friction measured. The B3 is also there is a tension adjustment here. It's basically there's a kit, which is basically a calibrated spring that can adjust belt tension if it becomes loose over time. Same mounting options as the screw driven. It's in the Your Motor Here, so you can easily add gearboxes and motors. The belt itself is up to 40 millimeters diameter. It is a polyurethane steel reinforced HTD style. This can deliver in excess of 200 million linear inches of travel. These actuators were extensively tested in our laboratory with loads up to 500 pounds on them, and actually side loaded as well, which we'll take a look at here. We also have some internal bumpers to help prevent jamming, black anodized aluminum, and of course a stainless steel dustband. Let's take a look at sizes, 10, 15, and 20 size extrusions. The belt drive has up to 325 pounds of pretension, so it can move 325 pounds. We can put over almost a ton of direct load on these carriers, and with a stroke of about 6 feet, we can start reaching this 200 inches per second velocity. This chart here shows the relationship between motor RPM and linear velocity. The B3W10, we need to get up to about 3,800 RPM of the motor to achieve the 200 inches per second. Then as the drive pulleys get larger, the RPM goes down. The belt thrust capabilities of the 10, 15, and 20 are 150, 250, and 300 pounds respectively. So this is the amount of pretension on the belt when it leaves the factory. And this can be tightened over time as they stretch. Now, one of the versatilities of the B3W is that with this side-driven pulley here, shaft, you can jack shaft 2 actuators together to form a gantry. So it makes multi-axis setups in a mechanical sense easier to configure. Both the screw and the belt drive share the same carrier capabilities. Okay, now here's how we beef up these carriers here. We have the standard. Probably the most common is we have an auxiliary carrier, just a free floating. One's attached to the belt or screw, the other one's free floating. And this greatly increases the MY capability of the actuator, this bending moment here, and also doubles the MX across the short axis of the actuator. This wraparound, the dual 180, there's 2 rail systems, one on each side. So another one is bolted onto the other side. They're attached by a plate. And this increases the carrier capability without increasing the length of the actuator. Note that there's just one mounting surface here. This mounting would have to be more special. They have to take special consideration here. There are, of course, CAD models available, so you can easily fit these into see how they work in your application. For situations where we have a large load that could be offset and we don't have an exterior carrier rail, we bring out the dual 180 in 2, 3, and sometimes even 4 carriers. So this guy's a real beast, okay? But this can save the cost of an exterior rail and the setup of trying to align 2 carrier rails together. These are available in all extrusion sizes. Usually this dual, as we call it, is usually used in the 20 size, most typically. Here's the look at the bending moments here that we talk about here. The direct force on the actuator, we call FZ. And MX, the bending moment along the short axis of the actuator. And then there's the MY, bending moment along the long axis of the actuator. Note that, of course, with the long axis, you get more bending moment capability. The main takeaway here is that the difference between, there's a big jump up in moment capability between the 10 and the 15 sizes. But the MX is going to be the lowest number. This is always going to be a primary consideration. These charts here show when we add the auxiliary carrier and the dual 180 carrier, how the moments increase. And once again, there's a big jump between the 10 and the 15s. It's very notable. There is a minimum distance center to center between two carriers. So these are some of the main takeaways from this presentation here and why we would use the B3. It can carry a heavy load. All these carriers are designed with the large ball bearings. They can handle offset loads, which are often found. They can save the cost and alignment of auxiliary rail systems. The work point deflection, the amount of deflection of your load out here stays consistent throughout the life of the product. These specs are in our catalog. It's a little bit too numbery to put in the presentation today. These can be used in 100% duty cycle, so they can be used continuously. Not all actuators can actually make that claim. And these can be used purely for thrust as well. It should be noted that the versatility of these is that they can carry a load, they can push, pull, they can lift. So they can do things that the rod actuators might not necessarily be able to do. One of the applications that we've designed in the past in the paper mill here, they wanted to replace a rack and pinion system, a 2-axis and give it some heavy load capability, but also precision positioning and less maintenance. So what Tolomatic designed then, or specified, is a combination of B3W and B3S. B3W for the long axis, and the B3S15 dual wraparound for the lift capability. We were able to sell 3 systems and a pretty good profit here. So here's what it looks like pictorially, and then here's the actual application here. And it looks like this has probably about 3 feet of vertical lift here. So that concludes our B3. There are 2 more heavy duty actuators in this Rodless family here. This one pictured here is what we call the TK system, TK actuator. TKs are also available in screw and belt. These actuators have some special characteristics that basically extrusion based don't. The TKS is a machined flat and straight actuator. It's kind of a mechanically, I guess you could call it a Cadillac. The flatness and straightness, once it's constrained, are a fraction of 1/1000th per foot. They do have very high thrust capabilities as well. And one of the most notable qualities of these is that they have a extremely high rigidity. There are 2 THK rails in here spread out. And that's particularly useful when you want to pick and place really precisely, or more likely when you're machining for precision machining. You don't want your tooling to deflect. So the rigidity is really important. They're very useful in multi-axis applications. They can bolt together very easily. They are low profile as well. The moment capability is moderate. They're not quite up to the B3S, but they're comparable. 3 sizes, and there is a significant jump up between the 10 and the 25 size. Looking at the interior of this guy here, these rails are machined flat and straight. The coupling is hidden within the actual body of the actuator, kind of unique to the TKS. We still can fit many motors on here, probably a little more customization, but that isn't a problem. This actuator is mainly bolted down mounting holes directly in the extrusion, not seen here. They do have internal switches, so that's all covered up for end of travel and home. The standard design, you'll notice there's just a cover on here. This is actually open, but there is a bellows option. So when we get into those machining applications with the chips or coolant flying around, we do have a way of covering this up. We do have an auxiliary carrier option, so we can put 2 carriers on this axis, which greatly increases the MX and MY moment capabilities. Excuse me, I have to move my phone away. Okay, 3 sizes here. The thrust, up to 3,200, over 3,200 pounds with a, I believe a 1-inch diameter ball screw. 1,500 pounds of downward pressure can be applied to these. And we can get fairly high speeds with our belt-driven TKS. Here's a look at, actuators are usually moving, so these dynamic loads are probably the most important here. I like using the Imperial units here. So you'll notice a large jump up between the 10 and the 25 size. Be the main takeaway here. And finally, a derivative of the TKS, we got the TRS. Actually, it looks very similar, but this guy is enclosed. But this has all the features of this TKS as far as rigidity, flatness and straightness, and moment capability. This actuator was designed for an OEM that wanted to do some very precise machining, which we'll take a look at here. They needed actuators that are particularly rigid. These guys are built beefy, so they easily bolt to each other. We currently have 100 millimeter frame size, a 165 millimeter extrusion. I'm thinking a 180 millimeter extrusion. These are actuators that, although they're not a standard product, they can be accessible via, best bet is probably to talk to your sales manager, a regional sales manager, and then we can specify which TRS to work for you. Like I said, they do have they're low profile, and they do have the flatness and straightness and the moment capability of the TKS. Here's a 3-axis application here. You move this way, and then up and down. And these are used to route aluminum window frames from large buildings. This particular application needed to drill things with circularity very round. And in this particular setup here, the circularity of the ends here of this groove was extremely important. You'll note there's plenty of aluminum chips flying around, but these are sealed. So he's got an IP44 to keep out the debris. And kind of in summary, these are the main considerations when we're looking at a rodless actuator. We have the various carrier designs. When we have to support heavy loads, okay, we have various designs. When we have multi-axis gantries, we can look at the various rodless. The B3 is particularly suitable for that. Speed considerations, we have belt technology for high speeds. Rodless actuators can accommodate long stroke lengths, long movements of tooling. And the other consideration was the environmental. We do have covered bearings. We do have, in the case of the TKS, we do have bellows options. So basically these are some of the main things to consider in the main application considerations. And then kind of in summary here, we do have the 4 main rodless actuators, 4 standards: solid nut and ball nut. The solid nut, which we probably didn't talk about here, is mainly for low duty cycle. Sometimes we need it to be very quiet. The solid nuts, being as the sliding mechanism, is quieter than a ball screw. We do have current sourcing and syncing switches. Most of these actuators are in the Your motor here, so we can easily integrate other manufacturers' motors. And all these actuators are stroke configurable, so you're not limited to 1 foot or 2 foot. You can get the stroke length that best fits your application. Then the main summary of our belt technologies, MXB and B3W. Now the B3W is covered. It has multiple mounting surfaces. MXB is probably somewhat, well, not probably, it actually is less, it's a little more cost effective in those applications that aren't, cleaner, because it does have an external bearing rail. And we do have in the what we call the reverse parallel, we do have 3-to-1 reductions. And of course, these are also stroke configurable. We have done up to 30-foot actuators for some years ago in a an application that builds truck catalytic converters. So we have gone up there. 30 feet is perhaps might be the longest practical stroke length.